So these are questions 4, 5, 6. They are dealing with moles, atoms, and total ions. And grams. So one thing to note for these, a mole, first off, is just a unit of measurement. So 1 mole is equal to 6.022 times 10 to the 23rd power atoms. So that's how many atoms are in 1 mole. You can have a different number of moles depending on the question. So you would multiply this number times your mole to find out just how many atoms are in that question. For example, you can think of a mole like 1 dozen. Well, we know 1 dozen really is 6, whether that's eggs, donuts, I guess, whatever you want to think of it. So it's just like that. 1 mole, 6.022 times 10 to the 23rd power atoms. Now, that's out of the way. If we look at question 4, 200 grams of a sample of pure MgCl2 contains how many formula units? Now, 5, if we look at 5, it says how many hydrogen atoms. Really, these two things are the same thing. So if they ask you about formula units or atoms, it's going to be the same process. The only difference is formula units are used for salts. So if we look at MgCl2, we got that chloride, then it's going to be formula units. But atoms we use for water, for example, because water is not a salt. So we start off with 200 grams of MgCl2. This over 1. And transferring atoms to moles, moles to atoms, grams to moles to atoms. It's all about putting the right proportion so that things can cancel out. So if we have 200 grams here of MgCl2 and we want to find out the formula units or the atoms, we need to first go from grams to moles to formula units. So how do we do that? Well, we use the molecular weights of the MgCl2. So here I've got magnesium weighing in at 24.305, and you can get this number from your periodic table. Then Cl2, well, if we look at Cl2 on the periodic table, it says 35.45, but there's actually 2 Cls or chlorines. So that means you have to multiply 35.45 times 2. So we got 70.9. So MgCl2 weighs 95.205 grams per mole. So we're going to multiply 1 mole of MgCl2 over the weight, which when you add it up, like I said, is 95.205. Right here, 95.205 grams MgCl2. So if you see here, the grams of MgCl2 cancel out. And if we do 200 over 95.205, we find out how many mole that is, how many moles we have. So go to your calculator, do 200 divided by 95.205. Man, I should have done this before. We end up with 2.101 moles. 2.101 moles of MgCl2 over 1. Again, because we canceled out the grams now. So now that you know how many moles you've got, remember last step is just going to your atoms, your formula units, and you just do that by multiplying 6.022 times 10 to the 23rd power to find out how many formula units, atoms, whatever the question may be asking you. So if you do that, 2.011 times 6.022 2 times 10 to the 23rd atoms over 1 mole MgCl2. Well, we can see the moles cancel out, and we end up with how many atoms? So if you do that, and I'm just gonna, hopefully you can see that. Yeah, you can see it. We end up with 1.27, just to make it easier. Really, it's 1.265 times 10 to the 24th atoms of hydrogen. Sorry, not hydrogen. What the heck? Where did hydrogen come from? Of MgCl2. My bad. But there we go. MgCl2. There we go. Okay. Then question 5. Same things. Oh, hydrogen. Sorry, I was rushing to the next question. So how many hydrogen atoms are present in 2.84 moles of water? This one has an extra step because they give us the moles of water. So we're going to have to make a ratio. So if we start 2.84 moles of H2O, but they want us just to find the moles, the atoms of hydrogen. So how do we go from H2O to hydrogen by itself? Well, we have to make a ratio. So for each mole of water, remember we want moles of water at the bottom, so every mole of H2O has how many hydrogens, or how many moles of hydrogen? Well, there's 2. So 2 moles of hydrogen. So just like we did before, we're going to cancel out moles of water, and we end up just with the moles of hydrogen. So 2.84 times 2 is 5.68 moles of hydrogen. Okay, so now that we got the moles of hydrogen, remember, how did we go from moles up here to atoms? You multiply 6.022 times 10 to the 23rd. You would do the same thing right here. Multiply 6.022 times 10 to the 23rd atoms of hydrogen, which would give you, bear with me, 5.68 times 6.022 times 7, 3.42. 3.42. Let's do 05 because there's a 6 after that. Times 10 to the 24th atoms of hydrogen. So there we go. That's where my hydrogen earlier came from. Okay. Now, in number 5, we've got a 10-gram sample of bismuth tribromide. But the difference here is they're not asking for formula units or atoms. They're asking for number of total ions. So for ions, again, it's going to be a little bit different, but we're going to start off the same way. First, we got to go from 10.0 grams of Br3, okay, times our molar mass, so we can get moles. Now, 208.98 for bismuth. Bromine has a weight of 79.904, but we got 3 of those, so don't forget to multiply. It gives us 239.712, and I don't know if you can see it. Oh, yeah, you can. Bismuth tribromide has a weight of 448.692. So 1 mole. Bismuth tribromide has the weight of 440.692. Okay. There we go. Okay. So, oh, I forgot to put BiBr3. Well, you get it. So grams cancel out grams. So that means I have to divide 10 grams by 448.692. Okay. So we end up with 0.022 moles. Of bismuth tribromide. All right. And here's the different step for the number of total ions. When you get your moles, you're actually going to multiply by how many ions you've got. So bismuth is 1 of your ions, Bi, and you've got another 3, Br, Br, Br. So 3 bromines. So in total, you've got 1, 2, 3, 4. 4 ions, and that's what we're going to multiply our moles by. So you get 0.089 equals, oh, times 4, sorry, don't forget. 4, because that's how many ions you've got. 0.089. And finally, we can multiply our 6.02 times 10 to the 23rd. So we can get the number of total ions. Now, there we go, you can see that. Just gave myself some more space. 6.022 times 10 to the 23rd. Yep. And that gives us our answer, 5.367 times 10 to the 22nd power. Ions, total ions. Okay, and there we go. That's it for questions 4, 5, 6.